Good morning. This is Adam de Leeuw, Technical Consultant at IBM. Thank you for joining me on this Watson Services Deep Dive Part 3. This is something that we're running to help you be successful with the Watson Build Challenge that we're also running at the same time. Today's topics are Watson Natural Language Understanding and its associated tooling, which is called Watson Knowledge Studio. So, as a brief reminder, we talked about this in the first webinar, but we have a service called the Watson Natural Language Understanding API or service, which is something you can use for advanced text analytics. So you can upload some unstructured data, and using its default training, it's able to extract key information and metadata such as concepts, entities, keywords, emotion, sentiment, etc. And it also has some options for customization, which is kind of the topic which we're covering today. So our goal here is to process unstructured data for a specific domain in order to be able to get those meaningful insights, in a similar way actually to how we would read and interpret content. Once we've got a way of extracting that information, then we can apply that to a task, potentially more efficiently than a human would be able to do that. So in the text on the left-hand side, you can see it's text about a road traffic accident that comes from a national database in America. And it contains details like the fact that an airbag was deployed and an accident happened between two vehicles at a certain date and time. So from that text, it would be useful to be able to extract that key information, like the make and model of the vehicles involved, the type of incident, etc. So you'll see how the unstructured text is being extracted using what's called an annotator component to provide us with that structured text, which we can later use for further analytics and processing. So let's have a look at an example of how fundamentally Watson is able to use an annotator to do exactly that. So in that text, you can see that Watson would be able to find spans of text such as John Smith, IBM, he, and Big Blue. They are mentions of what are called entities, and each one of those entities has an entity type. So for example, John Smith is a mention of the entity type person, and IBM is a mention of the entity type organization. Now Watson can also cluster those mentions together based on whether or not they refer to the same physical entity. So for example, John Smith and he are both entities of the words John Smith, and IBM and Big Blue both point to the IBM Corporation. Finally, Watson can also discover relationships between those entities as well, such as the fact that John Smith works for IBM in either of those two sentences. To achieve that task, we can use the tooling which I mentioned, which is Watson Knowledge Studio, to build an annotator to automatically find those kind of entities and relations. So what do we need Watson Knowledge Studio? Well, as you probably know, language is pretty ambiguous, and added to that, if you have domain-specific terminology, it makes it pretty hard to reduce this extraction task to simply kind of programming a system. Additionally, it can be difficult for domain experts and developers to collaborate and work together on this kind of task. And finally, this process of training a machine is pretty time-consuming and could get quite expensive. So that's really where Watson Knowledge Studio comes in. It provides an intuitive and collaborative and cost-effective approach for teaching a system to understand a particular domain. So the primary purpose then of Watson Knowledge Studio is to enable developers and domain experts to collaborate on the creation of these custom annotator components. It's a SaaS offering from IBM, and it's got a user interface that you can use to perform all of the tasks that you need to train either a machine learning annotator or a rules-based annotator, and we'll talk more about that in a few minutes. It can be used by people from different roles, so anything from natural language experts to data scientists to the subject matter experts themselves. And more importantly, it doesn't require any programming to achieve that task. So we're training Watson, not programming it. It's natively integrated with some of our other Watson offerings, so that includes the Watson Explorer product, which is an on-premises product, and also the Watson APIs that we've been talking about in this series, and that includes the Natural Language Understanding API and also the Discovery API. So let's have a look in a bit more detail about creating annotators and the different types. Watson Knowledge Studio can create both rule-based and machine learning annotators. Rule-based annotators are good in the cases where you can codify a set of rules to extract the information or the facts that you want to get from your documents. So that's ideal where the entities and all the relationships in the document are very easily defined with very limited variation. So for example, if your documents contained, let's say, mobile telephone numbers, they would follow a similar pattern, or in fact an identical pattern every time. So therefore it should be possible to code some rules or some regular expressions to be able to extract those numbers. Machine learning annotators work in a more similar way to human learning. So we observe things over time, and with repeated occurrences, we can tune our brains to learn from these patterns. These kind of annotators are useful where the text extraction is very complex or there's a large variation in the language. The process for creating a machine learning annotator involves using humans to create what's called a ground truth. So this is basically a set of example annotations which are then used by Watson Knowledge Studio to train a machine learning annotator. Both the rule-based and the machine learning annotators can be deployed to the Watson APIs like natural understanding, or alternatively, you can use the rule-based annotators as what's called a pre-annotator, which helps reduce the workload of the human annotators as they're creating that ground truth. Now, creating a machine learning annotator is an iterative and a multi-stage process, which is represented by the workflow you see in this picture. So if this kind of brief overview doesn't immediately make sense, then don't worry, because I'm going to try to show you this in the Watson Knowledge Studio in a few minutes when we start the demonstration session. So from the bottom left, you can see that an administrator initially creates a project, and then they must also create assets such as documents, dictionaries, and a type system. Documents need to be imported, which need to be representative of your domain content, and that set of documents is called the corpus, and later on a subset of that corpus is assigned to each one of the human annotators. A type system defines the entity types and relation types which are of interest to your particular subject domain. And therefore that also influences what the human annotators will be asked to identify in the documents which they use to create the ground truth. It's shown here as a project manager task, but the project manager may also need to consult with the SMEs to correctly define the type system at this stage in the project. Dictionaries can be imported or created, and they can be used in the process of pre-annotation to help reduce the workload for the human annotators. Now, the pre-annotation phase is optional, and I'm going to say a bit more about this on a subsequent slide, but briefly, you can use pre-annotating in a number of different ways. You can use dictionaries to pre-annotate documents. You can use rule-based annotators that you define yourself, or you can actually call out to the Natural Language Understanding API from Watson and use it to pre-annotate certain entities in the documents. Or, kind of getting ahead of ourselves a bit, but if you already have a machine learning annotator, then that too could be used to pre-annotate a new document set. Then we enter what you can see as the ground truth creation cycle. So the project manager has to provide annotation guidelines for the human annotators to follow. It's really important that each human annotator is consistent, not only with themselves, meaning that they do the first document the same that they do the last, but also with the other human annotators. Otherwise, you end up kind of mistraining the machine learning annotator. The project manager assigns what are called annotation tasks to the human annotators, which basically means that each annotator is given an overlapping subset of those corpus documents. And the human annotators then use the Watson Knowledge Studio tooling to manually annotate those documents, and I'll show you this later. They basically review those documents and they identify the mentions of interest and label them with the entity types from the type system. They also identify relationships between those entity mentions, and they also need to identify what's called a co-reference as well, which is a subsequent mention of the same entity but later on or in a different part of the document. Then you can enter the adjudication stage, and that's where the project manager basically needs to accept or reject the annotations from the human annotators. There's a scoring system that the project manager can use to compare the performance of each of the human annotators and look at the consistency between each one by comparing how they annotated the documents which overlap between the human annotators. Based on the annotated ground truth documents, then Watson Knowledge Studio can go ahead then and train a machine learning annotator component. It's important then to evaluate that machine learning component for its accuracy, and you do that by running it effectively on some of those ground truth documents, i.e. the documents which have been annotated by the humans. And again, there's a scoring system that can be used to compare how well the machine learning annotator does in its coverage of locating the entities, the relations, and the co-references. Based on that result, it might be necessary to cycle back and either update the annotations themselves by, for example, guiding the subject matter experts or the human annotators in how to do it differently or better, or maybe even going back and changing the type system, which would help potentially the annotators to do their work more consistently or more efficiently. Once all of that evaluation is complete and the scoring indicates that the machine learning annotator is working effectively, then directly from the Watson Knowledge Studio tooling, you can deploy the annotator to either the Natural Language Understanding API, the Discovery API, or the Watson Explorer tool. So, in summary, that workflow kind of boils down to these 5 steps. Creating a type system either from scratch or by adapting an existing one. Obtaining some representative documents of the domain content that you want to extract information from, which is called the corpus. Creating and uploading dictionaries and or creating rules annotators, which you can then use for bootstrapping the pre-annotation process. Then you can go through the process of performing the annotation of those corpus documents by the humans, and then based on that resulting ground truth, you can train the machine learning annotator and test it for its effectiveness. And if necessary, you can cycle back and repeat some of these steps. And not surprisingly, these are reflected in the user interface of the Watson Knowledge Studio as separate tabs, which you can see in the screenshot. Now, I want to say a little bit more about some of these steps before we dive into the screen share and look at the tool itself. The first step for defining a type system is basically to understand and decide what information you want to gather from the documents to solve your business problem. So, for example, if you're trying to extract information from medical records, then perhaps you might be interested in demographic data about the patient and their medical conditions and any medications that they've been prescribed. You should aim for a maximum of 50 entities in your type system, and ideally considerably less, because if and when you have a go at annotating a document using this type system, you'll find that if you have too many entities, it makes it quite difficult to hold all of those in your mind and find every mention of those entities as you go through the entire document. In many cases, you might want to start with an existing, more generic type system and then adapt it for your specific domain. On the Watson Developer Cloud website, there is a sample type system which you can download, which is called CLUE, and that stands for Knowledge from Language Understanding and Extraction. It has entities and relations in it that were derived by IBM Research based on the analysis and collection of various news articles. You might also find that there are industry-specific publications or dictionaries or ontologies that you could consider taking a look at to get an idea of the types of entities that you might want to define in your own type system. As you can see, the entity types and the relation types are mandatory. An entity type is basically how you categorize a real-world thing. And then when you are annotating the document, an entity mention is an example of something of that type. So, for example, if the document contains the words President Trump, you might annotate that as a person entity type. The relation types define an ordered relationship between two entity mentions. So it's the responsibility of the human annotator to look for text in the document which explicitly defines these relations and binds those two mentions together within a single sentence. The entity types can also be supplemented with optional entity type attributes to further kind of clarify that particular entity. So for example, if the document contained the word lawyer, then that might be classified as a person. But in some cases, perhaps if the document said somebody went to see a lawyer, then you might be referring, or the document might be referring to lawyer as an occupation. So, in those cases, you can use these kind of optional attributes like roles to help the annotators clarify the exact meaning of certain entities. So, as you're beginning to see, there could be many different ways of structuring the type system. So I'd really recommend that before you get started, you have a look at the best practices documentation on the Watson Developer Cloud, and it provides guidelines of when it's useful to use those optional entity type attributes, for example. Also, the way that you intend the type system to be applied by the human annotators could also be misinterpreted, and that's the reason why, if you're working with several human annotators, it's really important to create a kind of guideline document to help people understand your intentions. Now, as I've mentioned, to train the machine learning annotator, you're going to need a collection of documents to create this ground truth. They should obviously be representative of your domain content, and they should also contain relevant mentions of the kind of entities and relations that you're looking to extract eventually. The documentation provides some guidelines on how many documents are required. It mentions a total size, ideally, of about 300,000 words. It also suggests to limit each document to maybe a page or two of content. So therefore, if necessary, you could split the documents into multiple pieces. And this just helps the human annotators not get bogged down with too much information at once. And you should also aim to have at least 50 annotations of each entity type and 50 of each relation type when you finish the annotation process. A dictionary is basically a set of words or phrases that are equivalent for the purposes of information extraction, and they can be used for pre-annotation. So after the process of pre-annotation, it means that basically the human annotator can begin work on documents that have already been partially annotated. So when they open the document, they can expect to see that certain entities have already been highlighted for them. There's a few different approaches that you can use. So yes, you can use a dictionary annotator, and that might be best for document sets that contain fairly specialized terminology, because this approach doesn't consider the context in which the dictionary terms are used. So for example, it would be pretty easy to pre-annotate using a dictionary of, say, mineral types, so like calcium and sodium and stuff like that. But it would be more difficult to pre-annotate using a dictionary of common terms. So for example, if the document contained the word squash, then that might be part of an entity type for sports or vegetables, right? You can also use rule-based annotators that you define yourself. So as I mentioned, they're good for when you have common kind of repeating patterns or tokens. You can also call out to the natural language understanding API and use that to pre-annotate your document sets. It's got a knowledge base which is built from crawling web-based data. So this might be good for document sets which are rich in kind of general knowledge entities. And if you look on the documentation for Natural Language Understanding API, it actually tells you which entities it's able to identify. So you could start by having a look at that. Finally, if you have a machine learning annotator, then that too can be used to annotate a new document set. Conceivably, you could train a very basic machine learning annotator on just a few documents, and while it probably wouldn't be any good for sort of production use, it might be good enough for doing pre-annotation type tasks. So after the pre-annotation, then the project manager can create what's called an annotation task, and this really specifies which documents are to be annotated by which human annotators, and also it specifies the percentage of documents which should overlap between them so that scoring can be calculated to compare the results. The annotators annotate the documents using what's called the ground truth editor, which is a section of the Watson Knowledge Studio tool, which is what you see in the screenshot below. And as I've said, their goal, or the goal of the human annotator, is to label those mentions of entities, relations, and co-reference mentions, so that later on, the machine learning annotator can be trained to detect kind of similar patterns in documents which it hasn't previously seen. However, If your application or your use case doesn't actually need those co-references or relations, then apparently it can be good enough to do the training, the human annotation, just using the entities. So that might be a pretty good start for a POC. So while you might need quite a lot of documents, you could probably speed up the annotation by only annotating the entities, if that's adequate for your use case. So finally, before we have a look at the tool itself, then let's look at a completed example. So Watson Knowledge Studio uses some underlying language parsing features to automatically identify things like tokens, sentences, grammatic structures and stuff like that. And that's what you see represented by the first two boxes at the bottom, and they can't be changed or influenced. The remaining boxes, however, are influenced from the work of the human annotators. So you can see in this example that several people have been identified as mentions of the person entity in green, either by their name or where they've been referred to as husband or wife, for example. Subsequent mentions of the same people are identified as co-references, which is indicated by a little numeric tag next to some of those mentions. And finally, the relationship between some of the pairs of entities has been defined as well, and they flow in the appropriate direction. So all of those pieces of information, i.e. all the boxes at the bottom of that chart, are used by Watson Knowledge Studio to train a machine learning annotator. Okay, so we'll take a look at the demonstration now. I'm going to concentrate on the use case which I talked about at the beginning, which is about the car accident database. And we'll take a look at the type system which might be used to build an annotator to analyze that domain-specific information. We'll look at some example documents and dictionaries which are associated with that as well. I'll also show you how to make a rule-based annotator, which we can then deploy to the Natural Language Understanding API or use it for pre-annotation purposes. Finally, I'll also show you how the annotators use the ground truth editor to annotate documents used for training the machine learning annotator itself. So I'm going to start the screen share now. Okay, hopefully you're able to see my screen. If you go to the Watson Developer Cloud website, then as you know, this is where you can find all the documentation about the APIs from Watson. You could look at the Natural Language Understanding API. It's got a more detailed description of exactly what it means when I say things like concepts, emotion, entities, keywords, etc. You can also look at the API reference for this particular service, so you can read how to interact with it and find example code to help you get started. And there's also a link to the API Explorer. So this is a nice simple website where you see all of the different endpoints for each and every Watson API. And in fact, for the NLU API, there's just a couple to get to grips with. And you can expand these out, and then it helps you fill in the fields which are associated with the input and interact with this API directly from the web page. To use this web page, you simply need to put your username and password, which you get from your instance of the Natural Language Understanding API, which presumably you previously deployed via Bluemix. So we can go ahead and make some simple tests. So I've put some text in here, which is I love eating cheese and chicken. And in this box here, you can select exactly what it is you're looking to extract from that. So I've just randomly gone for concepts, keywords, and sentiments. And then it's simply a case of pressing the button to try it out, and let's see what results we get. So the results that came back include a pretty high score for a positive sentiment, which is good. And also it identified some keywords, which are cheese and chicken. And it also presented me with some concepts as well, that I was talking about food. And also, presumably, because I mentioned a couple of different sort of food groups within the same sentence, it's mentioned the concept of being an omnivore as well, which is pretty cool. You can also use the API with URLs as well as text that you provide yourself. So, for example, there is an article here on the web about how IBM created a new app for the Melbourne Australian Open that used analytics to provide some cool information for the fans, right? So I've plugged that into this API Explorer window here. So I've put the URL in, and this time I'm just going to go for the keywords, the main keywords in that document. So if we try that out, we can see what kind of results that we get. And you can see that for that URL, we see that the keywords in kind of descending order of confidence include Australian Open, Tennis Australia, the kind of analytics, and a mobile app. So that seems to have done a pretty good job. Now you'll remember that the whole point of this presentation is to talk about domain-specific text extraction. So let's see what happens if I put something in here to do with car accidents. So if I say a 2011 or 2012 Ford Focus crashed into a 1999 Nissan X-Trail, let's see how well the API does with that domain-specific text. So the results are that some keywords have been identified that do kind of highlight the cars that I mentioned, and it also extracts the concept of the Ford Motor Company, for example. But what it's definitely not done is, I explicitly identified to me which are the makes of cars involved, what are the models of cars involved, what year of those cars, what was the model year of those cars. And so that's okay, because that's exactly what we can use the Watson Knowledge Studio to help us with. So I'm going to take a look at the tool now. You access this tool via the IBM Marketplace. I'll show you a link to that in the references at the end of the presentation. But basically, you can sign up for the free plan, and when you log into the Marketplace website, you'll have a little icon here and a My IBM menu, and there you'll see a tile for any of the IBM SaaS offerings that you've signed up for, and in this case, it includes Watson Knowledge Studio. If you click on the link, it takes you to the tool itself, and here you can see that it's possible to create a project, which I've already done. So you can see along the top, we've got the main tabs, which correlate to the kind of things that I've just been talking about. So type system, documents, dictionaries, rules, and creation of annotator components. So let's start by looking at the type system for this car accident database. So you can see that we have some entities, and of course you can build this type system up directly in the tool or potentially import it from a file. So we've got entities that you might expect, which are related to our domain. So the manufacturer of vehicles, the model year, the people involved, the outcome of the accident, etc. We're also using those optional entity attributes as well, in this case the roles. So that's probably most easy to explain the reason why when you consider the model entity. So if you had a document that said the Ford Focus was traveling down the highway at the start of the document, then the word focus in that sentence is definitely referring to the model of a car. But later on, if in the document the author says something like the Focus was traveling at excessive speed, then when they say the word focus in that sentence, then it doesn't really refer to the model anymore. It's just a short way of saying the Ford Focus as a whole, which is really a reference to the vehicle itself rather than specifically the model. So that's why we have, in this case, we have the potential for adding a role to an entity to help the human annotator to clarify exactly what's meant. The icon here indicates that each one of these entities also has a relation associated with it. So the kind of relations that we've got here include things like caused by, occupant of, suffered from, etc. The kind of things you might use to describe what happened in the accident. So for example, you can see that a person could be the occupant of a vehicle, which makes perfect sense. But equally, a person could be the occupant of a part of a car, for example, a child safety seat. And there are other relations here as well. So you have an accident outcome, could be the outcome of a certain incident, such as a collision. So let's look at the documents now. So here I have imported some documents, and you can see if you look at these documents, they're quite short, and as I said, they're descriptions of the accidents from the national database. Once the documents are imported, it's the job of the administrator to also create what's called an annotation set. So if I click on here, you can select from the base set of documents, and then one by one you can create an annotation set for each one of the human annotators. Now in the free plan of this tool, you can only have one user ID. So that means the same person has to play the role of the project manager and potentially multiple human annotators as well. So it's difficult to demonstrate this concept, but in a paid-for edition of the tool, you would have multiple annotator names in here, and I could generate a set of documents for each of them, and then choose what percentage of documents I would like to have overlapping between each one of those human annotators. So you can see that I've already created a couple of annotation sets here. I had 10 documents, and I specified a certain percentage should overlap. So it ends up with each one of my human annotators having 6 documents each. And as you can see, unfortunately, they've both got the same username, but more realistically, there would be different names here. So looking at dictionaries, I've got a dictionary here for manufacturers. So in here, you find the main lemma, which represents a particular manufacturer. If I were to edit that, I could put different surface forms or different ways of referring to that manufacturer. So for example, I could put VW in here to represent Volkswagen. I also have a dictionary for models, so lots of different models of cars, and also a dictionary of vehicles, so the different ways that people might refer to a vehicle generically, like a coupe or a SUV or an ambulance or whatever. Okay, so now we've looked at the type system, the documents, and the dictionaries. We're going to take a look at what's involved in creating a rule-based annotator. So this is the editor for creating rule-based annotators. You can see on the right-hand side, I've already got started by creating what are called some classes. So classes are kind of like the rule-based annotator equivalent to the entity types, which we talked about in the type system, but they can be more fine-grained. And later on, in fact, we'll be mapping these classes, or at least one of these classes, to the entities of the type system. But for example, if you had an entity in your type system which was name, in the rule, in order to identify the pattern which represents the name, you might need to have a first name class and a second name class. So after you've created the classes that you want to work with within your rule, you can also map them to dictionaries. So here I've made a mapping between the manufacturer's dictionary, which we just saw, to the manufacturer class, which I'm going to be using in my rule. The same for the model. I've mapped the model dictionary to the model class, and the same for those generic ways of describing vehicles as well. Once you've done all of that, you need a document which contains an example of the kind of repeating text on which you want to base the rule-based annotator. So the document doesn't necessarily have to be one of the documents that you're planning to have the human annotators work on. It just needs to be an example that you can use for building and testing your rule-based annotator. The main options for creating annotators are to use a rules editor, which is what I'll be using in a moment, or you can use regular expressions, Java, using a Java syntax to create the rule-based annotators as well. So you can see that when I open the document, based on the input from the dictionaries, it's located various dictionary words in this text and then has mapped them to these classes which I created previously. Now the goal of my rule-based annotator is to find the model year for these vehicles, meaning I can automatically highlight that for the human annotators to save them a little bit of hard work. So what I'm expecting is in the crash reports, I'll frequently see this sequence of text, a year followed by a manufacturer followed by a model. And you can see that obviously in this case, the year relates to the model year of that car. So what you can do is you can basically highlight the sequence of text that which represents the pattern, and then it highlights the icon here where you can go ahead and create a new rule. So I'm going to call it the model year rule. Now along the bottom here, it shows me the tokens which trigger that rule. And along the top, I can map one of those tokens to one of the classes which I've defined here. So what I'm looking to extract from this rule is really the year. So I'm going to go ahead and assign the year to the model year class, which, as I said later on, will associate with one of the entities in the type system. So at the moment, this rule is only going to get triggered when there's a sequence of text which says exactly 2008, followed by a manufacturer class from the dictionary, followed by a model class from the dictionary. So obviously that's too strict. I need to change it so that any year will trigger this rule. So if I click on the 2008 token and click the properties button, I can say that instead of requiring it to be exactly the text 2008, I could say that it should be a part of speech numeral with a length 4. Now if I close the properties and save the rule, then the document opens again. And this time you can see that the 2008 has triggered my rule because it's the correct sequence of tokens, and that has been highlighted as a model year class. And the same is true here for the 2004 Nissan Pathfinder. There's another date here in the middle which isn't associated with the make and model of a car, so that hasn't triggered the rule, which is good. However, here we've got an example where there's a 2005 Acura RSX, and that hasn't correctly triggered the rule. And the reason is because the manufacturer was known, because it's highlighted as a manufacturer class and it was in the dictionary, but the model isn't known. So what we need to do is we need to edit the rule again, and we can potentially improve it by clicking on the model class, opening its properties, and saying that the model should occur 0 or 1 times. So in other words, we make it optional. So now if we save that rule once again, you can see that this time the 2005 Acura RSX has triggered our rule correctly. So now that we've finished creating a rule in our rule-based annotator, we can look at how you can go ahead and create a rule-based annotator to make use of that rule. So you do that on this tab here. You can click on the button to create an annotator and choose from the different annotator types. In fact, I've already created a rule annotator, so I can't select it again. But if you look at the properties of this rule-based annotator, you'll see now this is where you make the mapping between the class that we made in the rule editor, which was the model year class, and the entity from the type system, which we're hoping to use this rule-based annotator to pre-annotate. The last time, or previously when I made this rule-based annotator, I had a second rule in my rule editor which was all to do with vehicle class, which I've subsequently deleted, but that explains the second mapping here as well. Now, you can either, as I said, use this annotator for pre-annotating, or you can publish it to the Natural Language Understanding API, although disclaimer, it says at the bottom here that at the moment that's for experimental use only. The deployment process is straightforward because you can do it directly from this tooling. So here you can create versions of your rule-based annotator, and when you're ready, you can choose to deploy it directly to, for example, the Natural Language Understanding API. That interacts with Bluemix, and it gives you a list of all of the spaces that you've configured on Bluemix, and then you can choose the service instance, i.e. the NLU service instance that you want to deploy this particular annotator to. When the deployment has finished, then you get back a model ID, which of course you can use in your interactions with that API. So in actual fact, we can probably try this out. So you can see I still got the text here, which is about my 2012 Ford Focus having a crash. What I need to test this out is the model ID, which I previously got back when I deployed that annotator. So I'm going to take a copy of that, and there should be a field in here where I can paste in that model ID. Now, my rules-based annotator is only going to provide me with details of entities. And in fact, as you know, it's only going to provide me with one entity, which is the model year. So I'm going to change the requested feature to request only the entities. So let's see what happens now if we try it out. So this time, the response is much more domain specific, which is exactly what I was hoping for. So you remember that I mentioned 2 cars with the model years in the text. It was the 2012 Ford Focus and a 1999 Nissan X-Trail. And my rule-based annotator, my custom annotator, has successfully identified those 2 years and highlighted them as instances of the model year entity. So that's great. Let's go back to excuse me, the Knowledge Studio tooling. If we go back to the annotator components, if you want to use the rule-based annotator as a pre-annotator, then that's really easy as well. All you need to do is click on the Run icon here, and then you can choose the document sets, which you'll remember we set up previously, 1 per human annotator. So you can choose the document sets that you want the rule-based annotator to run on. When you've done that, and then we're really into the process now of human annotation. So it's the job of the project manager to create an annotation task, which is really easy to do. On this tab, you simply click on Add Tab, and I've already done this, but you give it a title and a deadline. Then within this annotation task, then you can add the annotation sets, which we set up previously. So that was a subset of the documents for each human annotator. Now, as I'm the project manager, then I see all of the tasks for each one of the human annotators listed. Obviously, if I logged in as a human annotator with a different user ID, I would only see the work for that particular annotator. So you can see that my 2 annotators have got some work in progress. If I click on the Annotate button here, you can see the list of documents which has been assigned to that first annotator. If I open one of those documents, you'll see that some pre-annotation has been successfully performed. So you can see that our model year has been successfully highlighted thanks to our rule-based annotator. If we look again at the list of documents for that particular annotator, you can see that at the moment they've got 1 document which they've submitted as completed and another one which is in progress. So let's take a look at this one and see how they're getting on. This is the ground truth editor. On the left-hand side, you see the main activities, which it's the responsibility of the annotator to do, which includes identifying entity mentions, identifying relationships between those entity mentions, and identifying co-references of those entity mentions. You can see on the right-hand side, we've got a list of all of the entities in our type system. And this particular annotator has done a pretty good job of annotating this document so far. So for example, they've highlighted that the high back booster seat here is a part of the car, and equally, even when it's referred to as simply BSS, it's been annotated as part of car here. They've identified some people, and so on and so forth. If you want to identify some further entities, then it's simply a case of clicking on the word and then choosing the entity type which that mention relates to. For the relations, this human annotator has made much less progress because they've only so far made 1 relation between these entity mentions. So they're saying that this male suffered from the accident outcome which is specified here. As you can see in the graphical user interface, it shows you basically all of the entity mentions which the annotator has previously made on the previous tab, and it's up to the human annotator to look at each one of these sentences and then determine if there are any more relationships to make here. So for example, if I decided that the part of car had a relationship between the model and I might say it was located on. So in this case, what I've said is the part of car which is the booster seat is located on the model, which is the model of the truck. Of course, I would have to refer to my annotation guidelines to make a decision whether I'm supposed to make that relationship between the part of the car, the booster seat, and the model, or maybe on the vehicle, or what's the best practice to be consistent. But that's how you go about creating these relationships one by one. For the co-references, at the moment, the annotator has only made 1 co-reference chain, which is number 1, which you can see on the right-hand side here. As I hover over that, it highlights the co-reference chain in the document, so you can see that it relates to multiple mentions of that high-back booster seat. If you click on the link here, it shows you the mentions of that text in the context of the document in a slightly different way. Also in the text here, you'll see that each mention has this tiny number 1 underneath it, which links together the co-reference chain. As a human annotator, if I want to create some further co-reference chains, then I can say that perhaps the male and he and the child, and also mentioned here and here, represents the same entity mention. I click on them one by one, and then I click on the first entity again to complete that co-reference chain. So as I'm working through this annotation process, obviously I can save my progress. When I'm ready, I can save the document as being completed. Looking back at the view of the administrator, at any time during the annotation process, the administrator can calculate what's called the inter-annotator agreement score. And this is something that the project manager can use to compare the performance of multiple human annotators. So assuming that the human annotators have annotated documents which overlap between them, then these scores can be calculated. You can get an overall statistic which shows you how similarly they're applying the annotation guidelines. And the closer to a value of 1, then the more similar the annotators have been working. And you can do that on a per mention basis, which you can see here, or you can do it on a per relation basis, or you can do it by looking at the co-references. You can either compare two humans. Again, you can see we have the same user ID here, but ideally there would be different users. Or you can do it on a per document basis as well. So once the project manager decides that the inter-annotator agreement score is sufficient, well, in fact, if he decides that the inter-annotator agreement score is insufficient, then the project manager can feed back to the human annotators that they're doing it differently and they should revisit some of the annotation activities. But once the inter-annotator score is sufficiently high, then it's up to the project manager then to allow the documents which don't overlap to be added to the ground truth. But for the documents which do overlap between human annotators, the project manager enters a phase of adjudication. And I can't show you this because I haven't finished the annotation process in the tool myself, but what it basically means is for the documents which do overlap, the tool will not let you add those to the ground truth until the annotations are exactly the same. So that it may come to a point where the project manager can't give any more feedback to the human annotators, and it's better now for the project manager just to correct one or two slight differences between those documents, make them the same, and then commit those documents to the ground truth. Once they're committed to the ground truth, then of course we can go through the phase of creating a machine learning annotator. And again, that happens on this menu here. You click on the button to create an annotator. I haven't done this myself because once again I haven't completed the annotation. And to be fair, I've only got 10 documents in my example data here. So even if I did complete the annotation and create a machine learning annotator, then probably the result wouldn't be that good anyway. However, creating a machine learning annotator is pretty straightforward. You choose the document sets which have been promoted to ground truth and would obviously be completed, and you choose a percentage of those documents which you want Watson Knowledge Studio to use to train the machine learning annotator. So in this case, it's suggesting that you take 70% of the ground truth for training the annotator, and then you can reserve, let's say, 23% to test the machine learning annotator later on. So you're running that test by comparing the results of the machine learning annotator to those documents which have been annotated by humans, but were not part of the training of the machine learning annotator. So they're effectively documents which the machine learning annotator hasn't previously seen. And again, you get some scores to indicate to you how accurately and how consistently the machine learning annotator is working compared with the work of the human annotators in creating the ground truth. And you can also save a small subset as well for what's called blind set testing. And that's where you might go through a few cycles of training and testing using these documents and just reserve a few documents for the kind of final testing at the end. So although I haven't actually completed the annotation process and created a machine learning annotator, somebody else has gone to that trouble for me. So there's a website where somebody in IBM has deployed this machine learning annotator, and they have exposed it so that I can test it out via this website. So you can see here that I put in some text which is representative of one of the documents from my data set, and I'm going to try to analyze that using the traffic incident reporting machine learning annotator. So you can see that along the top here are the entity types in our type system, and they have been automatically tagged out in the document as you would expect. So you can see, for example, that the driver is an instance of the entity type person. If I hold down Control as I hover over those words, it's slightly strange the way that it presents it, but you can see that the driver is an occupant of the front row. For example, you can also see that the driver suffered from minor injuries here. So that pretty much concludes the demonstration to the slides now, and hopefully I can draw your attention to a couple of remaining slides. So here is the link that you need in order to sign up for the Watson Knowledge Studio using the free plan. That's pretty straightforward. I also have a whole load of references in here as well. So there's a launch blog which talks about Watson Knowledge Studio briefly. There's more detailed documentation which I thoroughly recommend that you review. There are a couple of YouTube series which you can look at. One is at a kind of getting started level, and one is at a more deep dive level. And there's also some further video education as well, which is called the Watson Knowledge Studio 201. It's a little bit out of date. It doesn't include details about the rule-based annotator, which I just showed you. But the remainder of this information is very detailed about creating a machine learning annotator. And finally, just to perhaps reassure you about how much effort is involved, there's also a blog here where somebody trained a machine learning annotator using Watson Knowledge Studio to understand the sort of main concepts in a short story, and they were able to do that in 3 hours or less. So that pretty much concludes what I wanted to tell you today. If I could ask Izzy to start the poll for feedback, I'd appreciate that. I hope you get the idea of how you can use the Watson Knowledge Studio tool to train the natural language understanding API to understand the specifics of a particular domain. I'd encourage you to sign up and give it a try with some example documents for your own use case. If you need any help or want to understand why it's not performing as well as perhaps you hoped, then please do get in contact and we'll try our best to help you. But otherwise, I wish you the best of luck with the Watson build. Thank you very much, and goodbye.